So what we're going to do today is we're going to carry on from where we were yesterday, and I'll start with a series of slides showing that spinal cord reflex. Now, one of the ideas I want you to hold on to from this initial part of the lecture today, which will mostly be on slides, is that the spinal cord reflex is confined to the spinal cord. One of the things we're going to do by the end of today's lecture is we're going to start making cuts in the spinal cord. And once we start making cuts in the spinal cord, we're going to interrupt the flow of information as it moves up and down the spinal cord. Now, one of the ideas to hold on to when we walk through the initial segments on the spinal cord reflex is that's within the spinal cord itself, and that information does not have to be carried all the way up to the brain and back again to get the proposed movement or the proposed effect. That what we will do next, though, after we talk about these reflex arcs, is we're now going to talk about how information is delivered to the cerebrum, how it's delivered to the somatosensory cortex, how this information gets to the part of the brain which now can sense the world around us. As we go through today's discussion, there's these terms I've put on the board so you can quickly refer to them. They're the kinds of terms that you'll need to be immediately familiar with. And, of course, when we say ganglion, we mean a collection of neuronal cell bodies in the peripheral nervous system. And the one we're going to be talking about today is the dorsal root ganglion. The equivalent of a ganglion in the central nervous system is called a nucleus. And, again, they have these weird Latin plurals, where ganglion is ganglia, nucleus is nuclei. But again, keep those separate. And as we said last time, the tract is a bundle of conductile processes in the central nervous system, and a nerve is a bundle of conductile processes in the peripheral nervous system. So again, this is important to keep your head around as we walk through things today. And then finally, this is a really important point that comes up all of the time. And this is the nomenclature that we use in the central nervous system. This nomenclature is the nomenclature of tracts. And I'll emphasize it when we get to it, but one of the ideas you'll need to hold on to is that the nomenclature has two syllables. The first syllable is where the neuronal cell body or input region is, and the second syllable is where the output region is. So if you have a neuron, and we're going to talk about it here in a moment, which is spinothalamic, that tells you the cell body or input region is in the spinal cord, and its output region is in the thalamus of spinothalamic. And this is true for all or any manner of these different pathways. And put your phone away to appreciate it. Thanks. So now what we're going to talk about, though, is how we get this information up the cord. These are the so-called ascending pathways. So where yesterday's discussion was the circuit within the cord, we're now going to pass this information up the cord. And we're going to talk about two separate pathways. One pathway is going to carry information about proprioception and fine touch. Proprioception is part of that stretch receptor reflex that we talked about yesterday. But now we're going to follow those neurons, not just into the spinal cord and the reflex pathway. We're going to follow those neurons as they go and send their information to the somatosensory cortex. Information about proprioception and fine touch will be carried in this pathway, the dorsal column medial lemniscus, also known as the posterior column medial lemniscus, and we'll draw this pathway. The other major pathway we're going to talk about is the pathway that's carrying sensory information about pain, pressure, and temperature. The pathway carrying information about pain, pressure, and temperature is known as the spinothalamic tract. Again, there's meaning. Spino tells us the neuronal cell bodies are in the spinal cord, and it tells us that their output regions are in the thalamus. And we'll draw the anatomy out, both to show the language and to show what the pathways are. Now, these pathways are remarkably consistent, with a couple of important subtle differences. But in both cases, there's a three-cell pathway. We start out with a primary sensory afferent. Whenever you see this term, primary sensory afferent, remember the neuronal cell body for a primary sensory afferent is going to be in the periphery in the dorsal root ganglion. The primary sensory afferent not only has a process in the periphery, but it also has a process that extends into the central nervous system. And of course, that's what we saw yesterday when we followed that pathway that went in through the dorsal horn, down around to the ventral horn, and synapsed onto the second order neuron. And synapsed onto the lower motor neuron in the ventral horn. But again, we're going to follow this pathway, primary sensory afferent, now synapsing on to a second order neuron. But now we're going to see the second order neuron is found in a region called the dorsal column nucleus. The dorsal column nucleus is located in the brainstem. Now, the second order neuron, which receives synaptic input from the primary sensory afferent, then crosses over the midline. It extends over the midline and then sends its process to the thalamus. In the thalamus, the second order neuron synapses onto the third order neuron, and the third order neuron then in turn sends a process to the somatosensory cortex. Simple as 1, 2, 3. Just have to remember where these neuronal cell bodies are and where their output regions are. The anatomy of the spinothalamic tract is remarkably similar. It's going to contain 3 neurons, 1, 2, and 3. It begins with a primary sensory afferent. The primary sensory afferent enters the central nervous system. In this case, it enters the dorsal horn of the spinal cord. Now, the contrast between these two systems is in the case of the dorsal column system. The primary sensory afferent synapses onto the second order neuron, not until the brainstem. It goes all the way up. The process goes all the way up the spinal cord and into the brainstem before it forms that synapse. That ain't true for the spinothalamic tract. The spinothalamic tract, the primary sensory afferent, synapses onto the second order neuron almost immediately after entering the dorsal horn, entering the spinal cord. Then the second order neuron crosses over in the spinal cord and ascends the cord in the spinothalamic tract. So now it forms its synapses onto third order neurons in the thalamus, which then in turn, the third order neurons synapse onto neurons in the somatosensory cortex. So we'll walk our way through these 2 ascending pathways. And then we'll finish that story with something called Brown-Séquard syndrome. Brown-Séquard syndrome is where the cord is cut halfway across. It's called a hemisection. We don't cut it clear through, we only cut it halfway across. And we'll then see what kind of information gets through and what kind of information is blocked. And if you can follow it and understand it, you'll understand these pathways.